Hello, everybody. Good morning, good afternoon, good evening, and even good night for those of you who are with us, wherever you are on the globe. I think we can start. I see people dialing in. I think we're going to slowly start our second ClimateSCOpe, which is an international webinar, an initiative from the Space for Climate Observatory in collaboration with the UN Office for Outer Space Affairs. So thank you so much for your time. This second ClimateSCOpe will be dedicated to monitoring our forests, which is of actuality, actually, which is really trendy in the international agenda with the COP30. So many thanks to all of you who are joining us now. Let's start. Just as a friendly reminder, our webinar will be recorded and it will be available on the Space for Climate Observatory YouTube page very soon. So if you miss it, or if you don't have the time to stay with us for the hour and 15 minutes, 30 minutes, don't worry, you will have all the materials online afterwards. And if you want to give us your feedback as well, you will see the QR code on the right side of your screen. If you can already open it to save it for later, your opinion will be very much appreciated and will help us to tailor even better our ClimateSCOpe. So thank you very much. And without further ado, I think we can start in the substance of our ClimateSCOpe. So I would like to hand over the floor to Mrs. Laurence Monnoyer-Smith, who is the Director of Sustainable Development at the French Space Agency, also known as CNES, and also the co-founder of the Space for Climate Observatory. And she will tell us more about the Space for Climate Observatory itself so that you can get to know more about us. Thank you, Laurence, and the floor is yours.
Thank you. Thank you very much, Anne-Claire. I'm really happy to be with you for this second edition of ClimateSCOpe, because it's a great opportunity for all the members of the SCO community to gather and learn a bit more about each other. So just a quick reminder of where we are at the Space for Climate Observatory today. As you can see on this slide, we now are 57 signatories of the Charter, and the latest who joined us are the Vietnam Academy of Science and Technology and the Senegalese Space Study Agency, who just really joined us the last month. So we are still really open to welcome new members, new signatories, and more are to come this year, actually. So between these 57 signatories, they represent 32 countries, and we also have 3 UN programs and 3 international organizations which are part of our governance. Within the portfolio now, we've been running call for project for now 5 years, and we've reached the important numbers of 122 projects that have been accredited by the SCO. These projects are not only developed within the signatories countries, but pretty much everywhere in the world. We can see on the next slide maybe a map of the projects, where the projects are developed, and as you can see, you can find them pretty much everywhere. They are distributed across all 5 continents, and they address all the a wide variety of climate-related topics, dealing with biodiversity, dealing with natural disasters, water management, land use, urban adaptation, and also, which is the theme of our meeting today, about forests. We have pretty much today more than 22 SCO accredited projects that are directly or indirectly linked linked to forests. And what are they dealing with? They're dealing with deforestation, they're dealing with fire, extensive fires, with carbon credit, with biodiversity, and so on and so forth. Of course, as you have said, Anne-Claire, this year is we pretty much have focused on forests because of the COP30, which is about to start in Belém, and which will deal with the major issue of the state of Amazonian forests. So this is why today it's important for us to share those. Not all the project we've been developing within SCO, but some of them are quite emblematic, and that's what we are going to talk about today. So in this forthcoming session, we will present 3 SCO projects that have been working on the status and the evolution of forests around the globe. And so you will be hearing about TropiSCO, about CarbonAtlas in Thailand, and about CACAO in Italy. So thank you very much for being with us today. And as our international call for projects has just been launched beginning of September, and you still have another month, pretty much less than a month to send your proposal. Please feel free not only to ask questions to the project that are being presenting today, but also to ask questions to us if you want to know more, if you want to join, or if you even want to present a project for a SCO accreditation. So thank you very much for being with us, and I'll let you dive into the BIOMASS project now.
Thank you very much, Laurence, for this introduction to the Space for Climate Observatory. This is also one of the objectives of our ClimateSCOpe, so that you can know a bit more about the SCO and what it does and the portfolio of projects. So let's dive a bit more into the substance of our ClimateSCOpe, and I would like now to ask Mathew Williams from the University of Edinburgh to tell us more about the European Space Agency Earth Explorer 7 BIOMASS mission. Thank you so much, William, and please, the floor is yours.
Thank you very much, Anne-Claire, and I really appreciate the invitation, and good day to everybody. Thanks for giving me a chance to speak to you. Yeah, my name is Mathew Williams at the University of Edinburgh. I'm a member of the Mission Advisory Group for ESA's Earth Explorer mission, so I just want to acknowledge many colleagues and ESA involvement in this project. I'm very happy to report on this very integrated and collaborative work. Next slide, please. So I'll just summarize what I'm going to tell you in the next 10 minutes or so about the BIOMASS mission. It is the first ever spaceborne P-band synthetic aperture radar. So Earth explorers have as one of their goals to be innovative, and BIOMASS can certainly lay claim to that. The point about P-band radar is its long wavelength means it can see through dense forests, and it can therefore measure the woody biomass of the largest trees on Earth, and that's where most carbon is stored in vegetation. And the focus then is on the carbon cycle. And we are aware, of course, of how carbon drives climate, is also connected to life and the metabolism of organisms. So carbon storage in forests and how this changes over time is a vital piece of our understanding of the global carbon cycle, climate change, and the health of the overall Earth system. What BIOMASS will do is create detailed global maps of forest biomass and height. There's a little star there just to note that the focus is very much within the tropics, but that's where the key information requirement is, as you'll see shortly. And just to note, we have advanced techniques that are being used with the P-band radar. It will have both a tomographic phase, so for 3D imaging of forests, and an interferometric phase, which gathers more detail than the SAR polarimetry itself. So it's highly innovative in terms of the sensor and how it's being deployed in space. And while our focus is on forests, I should note that P-band radar offers unique capabilities for also measuring glacier and ice sheet velocity, mapping subsurface geology in arid regions, and, as we shall see, determining topography beneath dense vegetation. Next slide, please. So just to step back from that summary and give a little bit of background to that, if we look at a recent 10-year period of the global carbon cycle, we'll be aware that there are significant sources of CO2 addition to the atmosphere. Most of that comes from fossil fuels, around 90% of the source CO2, nearly 10 billion tonnes a year, comes from fossil fuel burning. But there is also a significant amount that comes from deforestation, and that's largely clearance within the tropics. Now, of that emitted CO2, around half of it is accumulating in the atmosphere and driving climate change. The other half is being driven or being absorbed as sinks into forests, vegetation and soils, or into the ocean. But if you see the uncertainties on those sinks into vegetation and ocean, particularly vegetation, are very large. So there is a great deal of uncertainty both in that deforestation flux on the left and in the land sink on the right. And that is the real driver for this mission. Next slide, please. This map just helps describe what we know about biomass currently. And the dark green shading on the map of the globe there shows where forests are distributed and where we think the most biomass is. And you'll immediately see that the tropics, within the tropics, particularly along the equator through the Amazon, Congo, Equatorial Asia, is where most of our forest biomass is held. But if you look at the figure on the right, the ground inventory density is the orange mapping, and that's a latitudinal slice showing where most of our forest plots are. And you can see they're very sparse within the tropics. And yet, as the blue line shows, we think the densest vegetation and carbon store is within the tropics. So we have a real data deficit in this area. Next slide, please. So that's just highlighting the importance of the tropics. So what information do we need? In order to help improve both the sink and source estimation, we need estimates of forest biomass and height and disturbances. And as we've seen on the previous slide, the crucial information need is in the tropics. That's where we can't rely on ground inventory and airborne data that we often have, for instance, in temperate latitudes. We also know that that's where the main deforestation is. We suspect that's where regrowth is also located, and the sinks may be located within the tropics too, and we have the least information and knowledge. Now, the scale of measurement needs to be at the scale of effective scale of change. So we need a satellite that's going to give us hectare scale resolution. And we are covering vast areas. This is why a plot network won't give us the information we need on the timescales we need. We need a satellite to cover these vast areas, particularly in the Amazon and Congo basin. And some of these places are very challenging to access, except from space. We need wall-to-wall data, repeated measurements, so we can explore change, identifying deforestation and growth rates. And in order to have effective information, we need our accuracy at 20% at hectare scale, comparable to ground-based observations. And that will allow us to detect the sort of changes that we're looking for. Next slide, please. So why P-band radar? I'm not a radar specialist, but this figure just emphasizes the role of wavelength of the radar and the objects that it interacts with. So we have X-band and C-band and even L-band sensors in space. Now, X-band is a very short wavelength. It's mostly going to interact with the smaller units in the canopy, so the leaves and tiny twigs. C-band will interact with slightly larger woody structures and twigs. L-band more so, but it's only P-band at 65 centimeter wavelength that you will effectively see through the canopy, see through the twigs and smaller branches and get backscatter from the larger stems. And that's what we want to measure. So that's why P-band radar is needed. Next slide, please. There are three innovative capabilities to estimate biomass. The most basic and ordinary way with synthetic aperture radar is to use emitted radiometric signals on different polarizations, so vertical and horizontal polarizations, and to measure the backscatter, again, in those different polarizations. And that gives you an opportunity to detect structures. And I'll show you some examples of that shortly. Next click, please. A second approach, though, is to collect those data from different viewing angles. It's a bit like binocular vision with our sight. If you look from, for instance, 3 different angles at the same location, you can use interferometry, well-developed methods, to actually detect the height of the object that's scattering back to the satellites. So that's adding a new set of information. And of course, height is a strong correlate with biomass. And then the next click, please. The third and really innovative way is to use tomography. And this will use 7 different looks at the same locations and allows, just like a CAT scan does on your body in the hospital, where you're scanned from lots of different directions to build up a picture of the inside of the body. Tomography will let us scan within the forest and see where the biomass is held in different locations at different heights. That's a really innovative approach that we'll be taking. Next slide, please. So what information will we get from biomass? It's going to deliver 200-meter resolution products on above ground biomass in tons per hectare and upper canopy height. And these will be produced every 9 months globally during the interferometric phase, so over around a 4-year period. And it's global coverage of forest, but it won't operate over North America and over Europe because of space object tracking radar reasons. And the accuracy measures are provided there. It'll give a finer resolution estimate of forest clearance because that's such a sort of all or nothing effect. We should be able to detect that at 90% classification accuracy. Next slide, please. So the satellite lifted off from French Guiana on the 29th of April, 2025. It successfully reached its orbit at 666 kilometers, and it has a polar orbit. Next slide, please. The antenna deployed in space. This is a little selfie that the satellite took of its 12-meter antenna unfolding in space. So that happened over the first week after launch. And that antenna is absolutely critical, of course, for both transmitting and receiving the signal at tiny, tiny wattages onto the Earth's surface. Next slide, please. So that's what the satellite looks like now in space. You can see that huge antenna oriented towards the Earth, and then the satellite itself, which contains all the power sources, communications, and the transmitter and receiver. So that is now in its polar orbit. Next slide, please. We're in a 6-month phase of commissioning, and that's brought us our first images. So just to set the scene, this is an optical image. So this is just a straight visual interpretation of a scene over Bolivia, where you can see a river and oxbow lakes and interesting different land use. If we go to the next image, this is the first view of that same location from biomass. And you can see the same structures jumping out there. You can see the water bodies that appear as a sort of very black coloring. Forest is the green. The purple colors are low stature vegetation, so that's likely pasture or shrub. So there's a very clear distinction now. What was all greenish in the last optical image now has a very clear separation because of the difference in the reflecting structures. So that's a really excellent outcome. And this was without any great deal of correction. This was literally straight off the satellite and analyzed. So it's very exciting in terms of the quality of the image that's been collected. Next slide, please. This is an image over Gabon in Africa, and a few things to note here. See the topography under the forest coming through. You can see both a sort of larger set of hills on the right-hand side, but also lots of dissected topography with drainage channels revealed in extraordinary detail underneath the forest canopy. And I think very exciting also is the orange coloration shows you the presence of flooded forests, where a double bounce indicates that there is water under the trees, and that creates a different signal to the terra firma, the drier forests. That is ecologically very exciting because it allows us to identify different functioning, different carbon storage likelihoods, different potential vulnerabilities to climate change, and different trajectories into the future of carbon storage. So really exciting images straight off the commissioning phase. And that's a great step for us going forward. Next slide, please. In order to get the most out of the information, it's absolutely critical to have a calibration process. And we're very pleased to have the GeoTrees activity that's been organized between a whole set of different organizations you can see listed along the bottom there. And this is about setting out high resolution, detailed forest plot network across the tropics, where you'll have a mixture of airborne laser scanning, forest plot inventory, terrestrial laser scanning, very strong engagement with local communities within each country, a common good, open science, and the GeoTrees is going to be absolutely critical for calibration of biomass and therefore generating robust data product. Next slide, please. So what are our next steps? The operational phase will begin in January next year, and that's the tomographic phase that will cover a 15-month period, generating this highly detailed measurement of forest structure. Then we'll have 9-month interferometric phases over a 4-year period. Calibration with GeoTrees will be ongoing, and we will be taking this information to give us better constraint on carbon cycling and address those sort of unknowns and uncertain processes that I showed in an earlier slide. Next slide, please. And I think I will stop at that point. That's just slide locates the key coverage, but I will stop at that point in the interest of time and hand back. Thank you very much.
Thank you very much, Matthew, for this very interesting but also very clear presentation about ESA's biomass mission. And I think this is also an absolute evidence of the critical role that our forests play. Thank you very much. Before we move to the 3SCOPE project, I would like to know if there are any questions from our audience. Let me see in the chat. I think I saw some. I saw one from Jival. With this increased resolution, does this mission also plan to tackle deforestation and its mitigation? Also, does this detailed idea of the forest biomass help better our estimates of yearly carbon absorption by the forest? And if yes, how do you see it impacting climate policy going forward? Matthew.
Thanks. Yeah, thanks for that question, Jival. Yes, the deforestation product that comes out of this should help us with better observations. Of course, tackling deforestation is a political issue, but the satellite will provide a new set of data that should improve our capacity to detect deforestation and therefore to support mitigation strategies. In terms of the detailed biomass data helping with carbon absorption estimates, yes, that is the idea, because we will get 9-month mappings of biomass. The potential there is for change detection, and particularly integrated with forest modeling approaches that also allow us to think about primary production and decomposition. We have an opportunity for much better estimation of carbon absorption by forests and their broader ecosystems. So that's exactly our goal.
Thank you. I see also another question. Is the secondary objective coverage in the MENA region for underground mapping or not?
Yeah, I guess I don't know what the MENA region is, but as you saw with the map, the image from Gabon, to see the topography under the forests is extraordinarily rich. In terms of desert regions, mapping through the sand is one of the goals, because the radar bounces off of water. So if you have very dry soil, very dry sand coverage, you should be able to see the desert geology below. So yeah, the fact that it's long wavelength means deeper penetration and better mapping is possible.
And we have our last question. How can those involved in national forest inventory and carbon estimates can contribute to calibration? What are the key data requirements and considerations?
Well, that's a great question, Shiva. I would encourage you to look at the GeoTrees activity, because that's a great way for contributing data and engaging with the calibration process. But I think in terms of national forest inventory, we would be interested to think also about those discussions at national level. So yeah, maybe Shiva, you could drop me a line and we could have a follow-up discussion on that. I'd be happy to talk about that. I'll put my email in the chat.
Wonderful. Thank you, Matthew. This is also about that, the ClimateSCOpe, about actually creating a network so we can all communicate with each other. So thank you so much. I think now we're going to move to really the scope portfolio with our 3 projects. And for that, I would like to hand over the floor to Alexia Fregno from the Space for Climate Observatory. She will present our 3 scope projects in which we're gonna dive into today. Please, Alexia, the floor is yours.
Thank you very much, Anne-Claire, and thank you, Matthew, for your presentation. It was very interesting. So now we are very thrilled to present 3 projects, 3 scope projects. So TropiSCO from France, supported by CNES, CarbonAtlas from Thailand, supported by GISTDA, and the last one is CACAO from Italy, supported by ACI. So to begin, we are very delighted to welcome Juan Doblas, who is a geospatial analyst at Globeo, which is a French company based in Toulouse. He will present the TropiSCO project, which aims to monitor tropical deforestation. So Juan, over to you.
Hi, thank you. Thank you all. Okay, so as I have been introduced already, I will say only that Globeo is a technological company which is hosted at the CESBio, which is the French laboratory for remote sensing of the biosphere, and we have developed this project with the collaboration of the CESBio and the CNES in the context of the SCOPE initiative. And I will ask you to point to the next slide, please. TropiSCO tries to address a big problem, which is the deforestation in tropical forest, which is an ongoing problem. As you see in this chart, in South America and Africa, the destruction of forests is still ongoing. In South America, the trends are becoming better, but there's still more than 2 million hectares per year being destroyed. In Africa, the trends are negative. And so as forests are destroyed, carbon is emitted, the climate change problems augmented. And also we have a feedback effect, which makes that as climate change worsen, temperatures rises, the forests are degraded, and so it's easier to provoke deforestation and through fires and whatever. So how do you tackle this problem? So historically, next slide, please. The best strategy is to monitor deforestation in real time, so you can deter it. So you can, when the deforestation is still a small hole in the forest, you can go there with your teams and stop it. But for this, you need to monitor in a real-time fashion. That's what has been done in Brazil. In the 2000s, the INPE, which is the equivalent of the CNES in Brazil, has developed a real-time deforestation monitor system called DETER, which help, together with the policies, as Matthew said, has helped reducing deforestation by maybe 4 or 5 fold in something like 10 years, as you see in the chart. The big problem of this kind of systems is they rely on optical imagery. As you see in the right side of the image, in tropical forest, the cloud cover avoids correct monitoring a good part of the year. As you see here, there's some periods where you have absolutely no cover of optical images due to this cloud cover. The solution for that is, and that's where TropiSCO enters, is, next slide, please, the use of radar sensors. Specifically, we use Sentinel-1. The Sentinel-1 is a constellation which is a synthetic aperture radar sensor, which is not blocked by clouds, as you see in those images. Here you see image in the left side, the radar image of a tropical forest, specifically in French Guiana. In the right side, you have the optical cover with Sentinel-2 satellites. As you see, there is consistency in the data coming from the Sentinel-1 satellite, which enables us to develop algorithms which can analyze those time series and in a very quick and trustful manner to detect changes which normally correspond to deforestation. We are not blocked by the clouds. We do that the whole year in a frequency that can vary from 6 to 12 days. Next slide, please. So we has starting from an idea, from scientific research, we have developed a operational method which now is applied over 9 countries in tropical forest, in the Amazon basin, in the Congo basin, and in Southeast Asia. And which is more important, we work with the spatial agencies of every of those countries to get their definition of forest, their mask, their data to customize detection to the needs of every country. We do so. We become operational, I guess, in 2022. We use time series from 2018, and we do with I guess a very high detail. We can detect deforestations as little as 0.1 hectare with a 10-meter resolution. And this is being used for mainly for deter deforestation, to stop deforestation when it's being produced, but also to make statistics and maps of environmental protected units for countries, and even for help certificate commodity trade. Next slide, please. So as we have deforestation maps, which are updated very frequently, we can build as well forest loss maps. If we superpose our maps of deforestation with maps of biomass, we can build charts like those in the figure, when we can see the carbon emissions almost weekly in several countries. Obviously, new data will improve this kind of computations, especially where we're eager to have the biomass maps to improve these kind of computations. We are also working on the integration of other sensors like GISTDA and NISAR to improve those carbon emission maps coming from deforestation. Okay, next slide, please. This slide tells a very interesting stories how we collaborate with the local stakeholders. In this case, we are collaborating with the INPE, the National Space Research Agency of Brazil, which developed that first real-time deforestation detection system to develop jointly a new system, which will bring the best things of the knowledge of the local knowledge of the INPE scientists and our method to create a new model, a new deforestation detection system, which is developing, is called DETER-IRTE, and will become operational, we hope, during the next slide, during the COP30, which will take place in the Amazonia next month. Okay, that's it. I guess I can show you now the platform where you can navigate and see deforestation in the countries we map. Okay, so I will share now. Can I share my screen? Yeah.
I think you can.
Okay. So it's as easy as going to TropiSCO.org. Up. And there you have our platform that you can put in good English. Okay, and here you see the map of the countries we cover. Yes, so you have Brazil, you have Gabon and Southeast Asia, and then you can approach them and you see deforestation data, which is updated in real time. So this, as you see, these colors mean the deforestation data, and you have deforestation data as far as today. So this system is being fed automatically today as new image of the Sentinel satellites are made available. So here you see an animation of deforestation. Actually, this is deforestation due to forest logging in the Congo Basin in the north of Gabon. You see how the roads used to logging to extract timber are being built. That's an example. You can also see the kind of a more classical kind of deforestation, which is deforestation for cattle here in Brazil. So I will be back to up. So here deforestation due to agricultural and cattle expansion in Amazonia is quite spectacular and a little bit saddening. Okay, this is happening like last year in Brazil. Yeah, you see deforestation coming through. And if you and as I said before, you can also have carbon emission data. If you click in one country or one province, you can see the carbon loss associated. You can see the time series of deforestation, and also you can see the carbon loss associated to this deforestation. Finally, I will say that, as I said at the beginning of my presentation, all the data produced by the TropiSCO project is free, open, and available in this page, the download page for all the countries we are working on and for all the years we have monitored. Okay, I guess that's all.
Thank you very much, Juan. So there are some questions. So yeah, you can access the platform on the following link and also on the QR code if you are interested in going through these maps. The first question is, can you be able to download statistics of how much forest was lost? So we can see that in your last presentation.
Yeah, you are able. The statistics, yeah, you have on the right upper right side of the chart, you have a button which is called export the chart, and you can export the chart you are seeing. Yeah.
Okay. And now, yeah, Juan.
Yeah, this is very good to watch Roma burning. Yeah, this is a great question made by Dr. Feja. Is very pertinent. The question is there any direct action taken on these illegal activities when it's monitored? Yes, I will say that I'm working personally on that. For example, with the INPE, we are feeding a database automatically. All those alerts goes to a database which is shared with the army, not with the army, but with the IBAMA, which is the environmental law enforcement agency in Brazil. So every morning, as those deforestation alerts are plotted in our site, they receive that on the database, and they will analyze and decide where to go. In order, it's a prioritized. They will choose the most dangerous alerts to go there by helicopter or by land and try to stop that. So yes, there's an action associated to those alerts.
We then have 3 questions. So you talked about the ESA's biomass mission, but how can this mission could contribute to your work? So that's the first question.
Yeah, so I guess biomass will contribute to first to upgrade our base maps to try to determine what is forest, what is not forest, because they will do like a 3D scan of the vegetation structure, so we can improve our base maps, and also we will certainly give better carbon loss estimations using the biomass data. Absolutely.
The second question is, what would be the process to extend TropiSCO to another geographic area? So you are currently working with Kenya, for example. So how is it working? How is the collaboration working?
Yeah, we need to understand it's a very good collaboration, but Kenya has very different kind of forest definitions. So we are working on that, and it is really interesting to collaborate with the local experts. And we can adapt and feed that on our algorithm. That's very good.
And I think the third question was quite already answered, but is TropiSCO used by local authorities to tackle illegal deforestation? So that's quite linked to the action question you answered.
Yeah. We are trying to, yeah.
There is another question regarding the expansion. Do you plan to develop this information for other South African countries, such as Peru, for example?
Yeah, there's an idea to expand TropiSCO to the Pan-Amazonian basin, which covers Brazil is only 60% of the Amazonia. The other 40% is in Colombia, Peru, Bolivia. So yes, we are thinking on expanding it. Yeah, it will be, that will be easier because the definitions of forests and the kind of forest is not very different.
And I think Faith already completed her question. You know, the question was, can you be able to download statistics of how much forest was lost?
Yeah.
And she also mentioned land cover maps. Is it possible to download?
We don't do that. Well, we use land use and land cover maps to build our base maps to see where there are forests or not at our starting monitoring data, but we that we produce deforestation maps, not land cover maps. But anyway, this you can refer to the articles and to the documentation of TropiSCO to see what kind of land cover maps we used to build our maize maps.
And that's perfect because you answered to the last question, which was again on the land use land cover map. So that's perfect. I don't think there is any other question, but again, I think Juan, if you want to give your email address, you can send it on the chat. Thank you very much for this fascinating presentation. And now we are delighted to welcome the Carbon Atlas project. So very briefly, so this project is led by GISTDA, and we are very delighted to welcome Sirikul Utasavi, who is Chief of Geostrategic Division at GISTDA. She will present the project CarbonAtlas-THA, which is a Thai project, which will provide input to improve forest carbon stock estimation in Thailand. So Sirikul, the floor is yours, if it works.
Hi.
Yeah, we can hear you.
Okay. So good afternoon, good morning, good night, or even good evening to everyone. I am Sirikul Hutasevi from GISTDA, the Geoinformatics and Space Technology Development Agency, Thailand. And it is very honored to be here to introduce our project, the Carbon Atlas Thailand, our satellite power platform that transform Earth observation and AI into digital systems for monitoring forest carbon stock. Carbon Atlas was developed to strengthen Thailand national capacity for measurement, reporting, and verification of MRV in line with Lake Plus and Paris Agreement commitment. Our goal is to really straightforward to provide accurate, scalable, and transparent carbon estimate from the national level down to individual plots, supporting credible carbon market and sustainable forest management. The platform is already operational, accessible through our portal and open API, so the user can explore it even integrate the data today. Next slide, please. Thailand forests are among the most diverse in Southeast Asia. They cover around 52% of the countries and act as essential carbon sinks that help regulate our climate. These forests are faced continuous pressure from deforestation and degradation, as the first presenter mentioned before, and this diminish their ability to absorb carbon dioxide. So to address this, we need credible MRV systems that are consistent, repeatable, and cost-effective. The traditional field-based approach remains significantly strong, but they are labor-intensive and hard to scale across large, complex tropical ecosystems. Carbon Atlas offers a solution by augmenting field measurement with space-based observation and AI-driven analytics. This combination allows us to monitor larger area more frequently at the lower cost while still maintaining scientific accuracy and transparency. We assess 5 key of carbon pools, including above ground biomass, below ground biomass, deadwood, litter, and soil organic carbon in alignment with IPCC guidelines and TGO P-World framework. Our system operates nationwide, calibrate across Thailand major forest types such as hill evergreen, mixed deciduous, dipterocarp, mangrove, and pararubber plantation. So the results are ecological meaningful from biome to district scale. Next slide, please. So you can think of the Carbon Atlas as a digital MRV platform. It automatically transforms satellite imagery and ground data into biomass and carbon maps, providing ready-to-use and T-World compliant output. Our platform supports the user at multiple levels, from policymakers, researchers, private investors, and community projects. It integrates Earth observation data and ground measurement to deliver transparent, verifiable, spatial explicit map of carbon stock. And because it's open and free to access, even smallholders can use it to estimate carbon credit for local initiatives. Next slide, please. This slide, we try to illustrate the scientific workflow behind the platform. We start by using the satellite input, a lot of sensors that we incorporate. We use Sentinel-1, Sentinel-2, BIOMASS-2, ALOS-2, Landsat-8, and also GISTDA LiDAR, combined with the topography from SRTM and land cover from Dynamic World. These databases provide complementary information such as the canopy structure, vegetation moisture, forest height, and terrain features. Together, all of them help to explain biomass variation. Next, we integrate the ground truth data for over 3,600 plots for the whole country, including 3,000 plots from local collaborators and approximately 700 plots measured by GISTDA using LiDAR terrestrial laser scanner or LiDAR TLS. You will see the TLS here. And this field data is very important to us. It helps improve and fine-tune our machine learning models to estimate biomass closer to realities. Our AI model primarily is a random forest and next-gen algorithm. Then they learn the relationship between these multiple sensor input and measure biomass to estimate above-ground biomass. The model output also includes the uncertainty layer, ensuring scientific transparency and the readiness for MRV application. The result map provides 20 to 30 meters resolution estimate of biomass and carbon across all forest types in Thailand, enabling the application in late reporting, national greenhouse gas inventory, carbon credit project, and community forest management. All outputs are accessible to RESTful APIs, allowing external systems to connect directly for automated workflow. Next slide, please. So now let's look at the platform. On the CarbonAtlas portal, users can explore 2022 above-ground biomass and carbon stock data for the nationwide. So you can see each carbon pools, including all of 5 pools for all of the province, 77 province in Thailand. And the user also can zoom from the province level into sub-district data, or even upload their own plot or like digitize the plot into the system. And then within the second, the system will return. I think it stopped the video. It will keep continue. Okay, the video, please. Okay. So you can select the province, district, and then sub-district, and then you just click the calculate. So the platform will calculate the carbon stock for the area. And also the user can even download the report that comply to keyword system in Thailand. So even the community, they can do their own like evidence base to do the credible carbon credit market or whatever by themselves. This is another way to get the value of the carbon stock. So you can digitize by yourself for the all of the area that you want to. Now we focus only on the green area, not include the agriculture area yet. So people can draw their boundary and then get the report, same as the previous one that selected by the the boundary, the political boundary. So now we have only 2022 data set, but the 2024 data set will be released on October 2025, which is this month. still on the way with subsequent update in 2026 and 2028. And then we plan to do it annually from 2029. Through the automation and open access, we can reduce the MRV cost by up to 70%, making the credible carbon accounting far more affordable in Thailand. So typical application can be include the carbon credit generation, forest carbon monitoring, green insurance and finance, and corporate and government climate reporting. Okay, even we don't have the demo today, you can go through our website. I encourage everyone to visit CarbonAtlas.GISTDA.or.th, which it has already have English version, so you can experience the platform by your own. We also have the reporting related to burn area in order to make like the whole complex of how we monitor the forest in Thailand. Okay, for the next slide, please. I will answer all of the questions at the last. Okay. So Carbon Atlas is truly collaborative effort. As I mentioned before, about 3,000 plots that we got from the collaborator. So bring together of all Thailand core institutions, which is the Royal Forest Department, the Department of National Park, Wildlife, and Plant Conservation, and also Thailand Greenhouse Gas Management Organization, or TGO, under GISTDA coordination. And we also have the international collaboration with NASA, the European Space Agency, or ESA, and Japan Aerospace Exploration Agency, or JAXA, and the Committee on Earth Observation Satellite, or CEOS, to ensure our scientific alignment and data interoperability. Beyond all these technical development, we also provide the capacity building. Recent example include training program for Malaysian Space Agency, or MISA, on the forest biomass modeling and plan. And we also plan to support Laos in conducting field survey in next year. So this will help strengthen the regional MRV skill. Our roadmap is move forward into 3 phases. The near term is we will release the 2024 update and expand the API integration with partners. For the midterm, we will refine the forest type model for higher accuracy. And for the long term, we will extend the MRV capability to additional carbon pools such as soil organic carbon. And also, we will support regional application across Southeast Asia. Next slide. So for the conclusion, I will come to the last slide. The Carbon Atlas provides an operational digital MRV service for Thailand, offering near real-time science-based data on forest carbon stock. It represents a practical step toward climate transparency, carbon market credibility, and sustainable land use planning. The system is free, once again, open, and continually improving through the collaboration. We welcome the partnership, whether for research, policy integration, or capacity development, to strengthen Thailand's contribution to global climate action. Additionally, we are open to collaborate on the first one, the biomass satellite, on calibrating and validation of P-band data from the biomass satellite by utilizing our ground data in Thailand. And thank you very much for your attention. I would now happy to answer all questions now. So we will start to read the questions first. I see a lot of them. Okay.
So there are a lot of questions in the chat. Alexia, if you want to read them through.
Sure.
Yes, so the first one, can you please advise what is the basis of the AI learning module?
As I mentioned before, we use random forest and MAC-ENS algorithms together. And the key is we fine-tune the model by the local data, the ground truth data that we have. So I think I have my colleague who work in this field. Actually, he is the project manager. Are you still here? No or yes? We will provide the manual, right? I sent to Alexia about how the method that we use in Thailand. We didn't invent any new things, but we read a lot of research and apply it in our country.
Thank you, Sirikul. The second question is, could this solution be replicated to other territories? So I think you talk about Southeast Asia, but is there any other possibility if some other countries would like to be interested by the methodologies or anything? Could this be replicated?
I think it's replicated. Everyone can use this model because of the key is the ground truth data. We need to have enough of the sample of the different and diverse in the forest type that cover your region. Because of the main input, it will be the satellite images and then go to the next end algorithm with the random forest. And the thing that you use to fine-tune the model is the ground truth data set that you measure the different type of the tree. So I think it can be repeatable in every area.
And the last question, did you already use the platform to calculate carbon credits, for example, for UNFCCC?
Yes, we propose for the country. So TGO is the regulator of the the people who respond to UNFCCC. So we use this to support them.
Perfect. I don't think there is any other question, but if you want to talk more with Sirikul, I think she can also give her email address so that you can contact her. Thank you very much, Sirikul, for this project presentation. Very interesting.
Thank you.
And now we'll have our last project, which is the CACAO project. Which will be presented by Simona Brandi, who is remote sensing analyst at Earth Sensing, an Italian company. So CACAO, very briefly, provides carbon credit tools based on Earth observation. So Simona, the floor is yours.
Thank you. I hope everybody can hear me.
Yeah, it's working very well.
Thank you for inviting us. And thank you for introducing me. So yeah, I'm going to spend the next 15 minutes to present our platform, which is CACAO, that stands for Carbon Credits AI Tools Based on Earth Observation. So actually, CACAO was born from the collaboration of 3 different companies, all of them based in southern Italy: Aerosoft, Latitude 40, and EWT. At the end of last year, so at the end of 2024, Aerosoft decided to create a startup, the one that I work for, called Earth Sensing, to completely focus on this project and on forest monitoring overall. So our goal is to make the carbon market more easy to access for everybody by developing an automatic monitoring, reporting, and verification system using remote sensing, artificial intelligence, and blockchain. At this moment, we are still in a validation phase. So our geographical coverage is just southern Italy, in particular the regions of Calabria and Campania, but we aim to make our solution as scalable as possible. Next, please. So yeah, to understand and to explain how our platform works, we need to address the challenges that the voluntary carbon market is facing at this moment. For those who don't know, the voluntary carbon market is a tool that anybody, starting from companies, organizations, individuals, can use to compensate their footprint, their carbon footprint. How? By investing in sustainable projects that can be reforestation or any other projects mostly in forest areas, but also in other sectors, but we are going to focus on the forest areas. So how to do so? The investment is called to buy carbon credits, which is the equivalent of some kind of permit that you are going to buy carbon credit, so you can actually release that kind of emission into the air. So it really sounds amazing, but at this moment the market is facing some kind of challenges. The first one is that computing carbon dioxide emissions is really expensive, because most of the time local surveys are needed. This makes the carbon market less accessible for small landowners. Therefore, the lack of an automatic method for calculating carbon credits offers low scalability, and there is a really high risk of greenwashing and double counting that is making the market less transparent and less secure. This is why we are developing CACAO, is our answer to this challenging. So next, please. Yes, okay, so what we want to do is to use remote sensing images, use them as an input to an artificial intelligence model in order to give as output a carbon storage map. And we want to make the transactions, so the buying, the purchase of the carbon credits, we want to make them more secure by using blockchain. In particular, we are going to offer to our clients two different kind of experience. On one hand, we have the landowners, where they can use our when they use our platform to evaluate the commercial potential of the area, to calculate the value of the carbon credits that they are going to generate. They are going to be certified, and then they can sell them. On the other end, the companies will be having access to a list of carbon credits generating projects, and they can choose the one that best meet their criteria in terms of proximity or carbon footprint value. We are relying on the certification and the standards of PEFC, which is a no-profit organization and a leader certification body in the sector of sustainable forest management, which means that we give the landowners a support throughout the whole life cycle of carbon credit generation, because at the basis of every carbon credit generating project, there is the sustainable forest management. And we can give, thanks to the collaboration to PFC, the support to actually obtain the carbon credit, the sustainable forest management certification that is fundamental to generate any kind of credits. Next, please. So yeah, as I said before, we are in a validation phase. Actually, we are starting a collaboration with the municipality of Moia della Civitella in the province of Salerno to create a forest laboratory where we can actually test our technology in real time, and therefore our stakeholders have an active part in the process, in the developing of our platform. We already have other municipalities that have expressed their interest to join our laboratory. Next, please. So yes, we mainly use Sentinel-2 data. As I said before, they are used as input to our deep learning model. And we are actually using, in particular, leader data for calibration and validation model, but we also rely on the Italian National Forest Inventory or other data sets that are offered by the Italian Forest Committee. As we can see here, we have an example of a carbon sequestration map. It is really easy to interpret. This one is for the region of Calabria. It is really easy to interpret. We have the darker area that are representing values close to 0 for carbon sequestration, and then we have the lighter ones, the yellow, that are representing higher value of carbon sequestration. So we can actually see where is the most sequestration. So yeah, next slide, please. Okay, so as I mentioned before, we have mainly two kinds of clients, and both categories will be able to interact through a personalized user experience. As for landowners, they will be submitting information about the areas, the location, the tree species, and then our model will compute the the value of carbon credit generated according to the PEFC standards. And on the other end, the companies will be able to submit all kind of information to compute their carbon footprint, and then they will have access to a list, and they will actually be able to monitor the project throughout its entire life. We have already engaged with different stakeholders, every kind of stakeholders, starting from the Italian Forest Association to different companies that want to meet their ESG criteria, that want to enhance their reputation, and as I said, public and private forest owner, for example, the municipality of Moio della Civitella, where we are already starting to collaborate. So I think my presentation, that's it. Next slide, please, should be the last one. Yes, so I hope everything was clear. If you have any questions, I'll be happy to answer it.
Thank you very much, Simona, for your presentation. If you do have some questions, please, you can type them on the chat. I do have one. How are you working with the Italian Space Agency, if you're working with them?
At this moment, we are just supported. We are not working yet, but maybe in the future.
Okay. And you also talked about expanding your solution at the international scale. Do you already know when it's supposed to happen? Do you already have some timeline?
We don't know, because at this moment, the market is going through a transitional phase. We are waiting for the European regulation to be fully operated in order to be compliant to it, and then we can start to actually go outside Italy.
Okay. We do have one question. So what do you need to go fully operational, and how can cooperation, both national or international, could help to go fully operational?
We think that it's really fundamental for us to start the forest laboratory, because by doing so, we can actually our stakeholders have like an active part, so we can actually be confronting and understanding their needs, and in the same time we are collaborating with PEFC with their standards, so we can have as many information as possible to be as more compliant as possible, because the problem of the market is that we need to respect different kinds of standards and stuff to be, you know, clean and transparent and secure.
Perfect, thank you. And maybe last question from my side. So you said that the solution is commercial, so it's fully commercial, or is there some open or available aspect of the solution that are open?
The solution is fully will be fully commercial. So yeah.
Okay. And we also have one last question. Is CACAO a business? And if so, what are the costs for businesses who would like to use your services?
Okay, so it is a business. We do have like a price list. At this moment, I don't remember the price because it's not like what I do, but if you want, you can write us an email, and we will be able to write the list and give you all the information. I can leave my email on the chat for any other questions, or if anybody has more curiosity.
That's perfect. Thank you very much, Simona.
Thank you.
I think we are now all over our scope project, so I will give the floor to Anne-Claire to close this session.
Yes, thank you very much, Alexia, and thank you to all our presenters today, to our 3 scope projects. And I think it was really interesting also in the current context and in preparation of the COP30, because we have actually seen how Earth observation and space data can actually solve many pressing challenges when it comes to forest monitoring. I mean, we have seen 3 platforms that help to calculate carbon credits, to obtain or be to abide with the PEFC certification, and also to gain ESG criteria. We also saw a platform that supports and help in combating illegal deforestation. And all the 3 projects actually work with local authorities and individuals. So this is really to also an evidence of the fact that space data is not just something very high level. This is actually something which is for the population, for the people, and the population are actually the end beneficiaries of those platforms. So I think this is very good to restate it. And also I think such a webinar actually are also critical evidence of this. So without further ado, I think we are going to close now. Thank you very much to everyone who watched and listens to us today. Please, if you would like to be informed about the next ClimateSCOpe and also all the news from the SCO, please scan the following QR code on your screen so you can be added to the SCO newsletter. The next ClimateSCOpe normally will be in January 2026. The thematic has not been decided yet, but we will let you know. So thank you very much. And just to recall again, this webinar has been recorded, so it will be available on the SCO YouTube webpage. So if you have missed it, or if you could not stay for the entire hour and 15 minutes, you can always retrieve it online. So thank you very much, and have a good morning, evening, afternoon, and night. Thank you.
Thank you very much.